Uh, okay. And then we have one question from those questions I've sent in the group. Okay. So this question I've written here is a free board diagram of question 2. Okay. That one of a robotic arm. Okay. So guys, the question reads to say, calculate the moments of the 250 Newton force about the base point O of the robot. Okay. So in this question, they're asking you to find the moments of the force about point what? Point O. Okay. So most of the time, my question is here. Okay. But what will help you is for you to draw a free board diagram. Okay. A free board what? Diagram. Okay. So this is a rough diagram of this question, okay? And then we have a force here of 250 Newton, okay? So how do we go about this question of finding the moment of the force about point O, okay? So we know to say the moment of the force is the product of force and what's perpendicular what's distance. That's the definition of the moment. Moment is the product of force and the perpendicular what's distance. Okay. So for this case, the distance given, we have the distance AB, and this distance is 400 millimeter, okay? And the distance from O to A, this distance is 500 millimeter, okay? Another distance, we have a distance A, okay? This distance is 300 millimeter, okay? So for us to find the moment of the force about point O, okay? So we are going to find, as you can see, this force given 250 Newton, it is going to have some components, okay? It is going to have some components where in the X and in the Y, okay? So this 250 Newton is going to have some components, okay? The force here and the force there, okay? So we can say this is the force in the Y and the force in the X, okay? So, so for us to find the components, we must have an angle either here or there, okay? For us to find the what? The components of a 250 Newton force, okay? So how are we going to find the component? First of all, we are going to find the missing angle. This missing angle will help us find the components of a 250 Newton force, okay? So for this case, we are going to draw a straight line, okay? Passing through point B, okay? We're going to draw a straight line passing through what? Point B, okay? So as you can see, for this question, the angle here was given to be what? What is this angle? Exactly, 60 degrees, okay? So as you can see, we have drawn a straight line here, okay? So as you can see, this, what angle can be here? Exactly, 90. So automatically, since you have two angles here, automatically you can find the missing angle there, okay? How are you going to find the missing angle, okay? So this is the true angle. Angles in a triangle add up to what? Exactly, exactly. So what is the angle there? What? Exactly, exactly. 30 degrees, okay? Have you seen how we are going so smooth? Okay. So apart from that, we also have a 20 degrees there, a 20 what? Degrees there. But as you can see, there is a line passing through B, okay? And there is also a line going in this direction. And as you can see, this is making a perpendicular, okay? It is making 90 here. So the angle here is what? 90 degrees. Okay? The angle there is what? 90 degrees. Anyone who is behind? Anyone who is behind? Okay. So no one is behind so far. Okay. So here we have a 30 degrees, we have a 90, we also have a 20 degrees. Okay. But there is also a missing angle here. So it is very simple to find this angle. How? So this is a straight line. Okay. A straight line adds up to what? Exactly. So it is easy to find this angle. How are you going to find this angle? 30 plus 90 plus 20. So 180 minus the sum of these three angles. So what could be the angle there? 40? Yeah. So the angle here is 40 degrees. Okay? Then, as you can see, here it is making a perpendicular. A perpendicular adds up to what? 90, exactly. So there is 90 degrees there. Okay? So since there is 90 degrees, okay, this is a triangle. A triangle adds up to what? 180 degrees. So it is very simple to find that angle. Okay? So what could be that angle? What's it? Okay. So the angle there is 50 degrees. Okay. The angle there is what? 50 degrees. Okay. So since the angle there is 50 degrees, now we're looking a way out to find the angle either here or there. Okay. The angle here or what? There. How are we going to find this angle? How are we going to find those missing angles? What are we going to do to find those missing angles? Anyone? What are we going to do to find this missing angle? What are we going to do? What? What are you going to do to find either this angle or that angle? What are you going to do? Let's just do the name. What are you going to do to find this angle? Yes. What? Exactly. Exactly. Have you seen this where there is a 50 here? It is making what? A 90. So there is a 90 degrees here. Okay. Already here we have a 50 degrees. So what are we going to do to find this angle? We're going to say 90 minus what? 50. Giving us what? What could be the angle there? Exactly. 40 degrees is the angle there. Okay. So since you have reached this far, now you can find the missing sides and you can also find the components. Okay. You can also find the what? The components. Okay. So what about this angle? This angle would be what? 50, exactly. 50 degrees. So let me draw a rough diagram here so that you can see how you're going to find the components. Okay. 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 So I can just say like this. Okay. So the angles are going like this and this. So this one is 50 degrees. So for us to find, this whole distance here, the hypotenuse is going to be 250 Newton. Okay. So for us to find the component of the force in the y and the component of the force in the x, we are going to apply what we call SOHCAHTOA. Okay? We're going to apply what? SOHCAHTOA. Okay? Therefore, sine 50 degrees is equal to opposite Opposite is the force in the y, okay? The component of the force in the y over hypotenuse. What will be our hypotenuse? What is our hypotenuse? Exactly. 250 Newton, okay? Therefore, force in the y is equal to sine 50 multiplied by what? 250. So 250 sine 50 degrees, okay? So the components in the x will be what? 250 cos 50 degrees, as simple as that. So for this question, we have found the component of the force in the y and the force in the x. Okay, we have found the component of the force in the y and the component of the force in the x. Okay, so the next thing here, we're also going to find the missing distances. The missing what? Distances. Okay, anyone who is behind so far? Anyone who has the question of how we are moving? It's very clear, okay? All right. So for this case, we're going to find the missing, okay? The missing what? The missing sides, okay? We're going to find the missing what? The missing sides, okay? So we're going to find the missing sides, the missing distances in short, okay? So here, the hypotenuse, we have a 400 millimeter, okay? So we need to find this distance and that distance using SOHCAHTOA, okay? We can either use this angle or that angle, it is okay. So for this case, let us use 60, okay? So it's like this. So we have 60 degrees and the distance in the y and the distance in the x. And we have a 400 distance here. Okay, therefore, sine 60 degrees is equal to opposite. Opposite is the distance in the x over hypotenuse, that is 400. Therefore, distance in the x is 400 sine 60 degrees, okay? So the distance in the x here is 400, okay? 400 sine 60 degrees, okay? What are the distance in the y to be what? To be what? The distance in the y. So same procedure, you can use SOHCAHTOA, okay? Cos 60 degrees is equal to adjacent. What is our adjacent here? Is the distance in the y, okay? Over hypotenuse, that is 400, okay? Therefore, distance in the y is 400 cos 60 degrees, okay? So the distance in the y to be 400 cos 60 degrees. 400 cos what? 60 degrees, okay? So since we have found the missing distances here, we can go to this other part. We also find the missing distances, okay? Okay. Okay. Okay, so the other part is like this, okay? And we have a distance here, we have an angle here, an angle of 50 degrees, and a distance of 300 millimeter, okay? So we can also use SOHCAHTOA to find the missing distances, okay? Therefore, sine 50 is equal to, our opposite is the distance in the x over hypotenuse 300. Therefore, distance in the x is equal to 300 sine 50 degrees, okay? Therefore, distance in the y is equal to 300 cos 50 degrees, as simple as that. So the distance in the x is what? 300 sine 50 degrees, and the distance in the y, distance in the y is 300 cos 50 degrees. Okay, 300 cos 50 what? Degrees. Okay, and yeah, that is it. So anyone with a question so far, or anyone who is behind of how we're doing these stuffs? Okay, so far no one is behind. Okay, so we can now find the moments of this component of the force in the y and the force in the x about point what? About point O. Okay, so therefore moment or the force about point O is the product of force and perpendicular distance. When you talk about perpendicular distance, means it is making a 90 degrees somewhere. Perpendicular distance is making what? A 90 degrees somewhere. Okay, so you can start with any force, either the force in the y or the force in the what? In the x. Okay, so for this case, let us start with the force in the y. This force in the y. Yes, I'm going to somewhere here. Okay, the force in the what? In the y. Okay, so since we are taking the force in the y, okay, you need to pay attention here. Since we are taking the force in the y, its perpendicular distance will be this distance plus that distance. Okay, since you are taking the force in the y, its perpendicular distance would be a distance from that point to the line meeting point O. Okay, therefore we're going to take the force in the y being multiplied with a perpendicular distance. A perpendicular distance of the force in the y is the sum of 300 sine 50 and 400 sine 60. Force in the y being multiplied with 400 sine 60 plus 300 sine 50 degrees. Okay, moment of the force. Okay, so since we are taking the moment of the force about point O, okay, about point O. So this force in the y, it's more like it's going anti-clockwise. Anti-clockwise means what? See? Positive. Not so? Anti-clockwise means what? See? Positive. If it was going down, it was going clockwise, and we would have put a negative here. Okay? So if you forget a negative, the answer will be wrong. So for this case, see, this force in the y was going anti-clockwise, means it's going to have a positive here. Same applies to this force in the x. It is also going anti-clockwise, meaning it's going to be positive force in the x. Okay, what will be the perpendicular distance of the force in the x? The distance in the y. What is the distance in the y? Okay, so the distance in the y will be what? See? What will be the distance in the y? 500. Can you find the moment about point O? You get about point what? See? Point O. If we were finding about this point, we would have taken on this one. But we are finding the moment about point O, means we are going to take the whole this distance in the y up to where point O is. Okay? Yeah. So it's going to be 500. 500. Okay? So we can replace the forces here. What is the force in the y? What is the force in the y? The force in the y, guys. This one we found here. Okay? Okay. 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 So the force in the y will be 250 cos 50. Okay? 250 cos 50. What is the sum of this? 400 sine 60 plus 300 sine 50. What is 400 sine 60 plus 300 sine 50? Anyone with a calculator? 400 sine 60 plus 300 sine 50. What? What? Okay, so you can also multiply that answer multiplied in advance with this one. Yeah, we're going to convert when we find the final answer. Okay, Kyrie, a moment to the force is measured in Newton meter, but for this one, it's going to be Newton millimeter, but we are going to convert it, okay, from Newton millimeter to Newton what? Meter, okay? So, have you multiplied? It's giving you what? 92597.3. What's it? That's all? That's all? Or 3. Okay? Plus the force in the x, which is 250 cos 50 being multiplied with 500. Okay? $250 cos 50 being multiplied with 500. 80 0348.45. That's all. Okay, so you can also do the sum of this plus this one. This is okay. The force in the y, the force in the y is going to be 250 sine 50. This one, huh? Yeah. So I put cos. Sorry. So it's supposed to be 250. Thank you very much. 250 sine 50. Okay. So which means this one was wrong. Okay. Thank you very much for the correction. So I can do the multiplication. The sum of this being multiplied with 250 sine 50. Okay? It's giving you what? The sum of this being multiplied with 250 sine 50. What's it? 110356. 5v3. That's all? 0.2015. And also this plus that one. Okay? This plus that one. Okay? 190,701.65. 15. That's okay. Okay. So it's supposed to give you Newton millimeter. Okay. So how are you going to convert from Newton millimeter to Newton meter? How are we going to convert from Newton millimeter to Newton meter? What's it? How are we going to convert from Newton millimeter to Newton meter? what? Multiply by 10 to the power negative what? 3. So can you multiply this answer times 10 to the negative 3? Okay, is equal to 190 point what? Okay, 0.7 what? Then you convert it to Newton meter. Okay, as simple as that. Tama question here put 20 marks. So which means, in fact, sometimes at 25. So means 25 was in. Okay. Yeah. So that's how we go about it. So anyone with a question? Anyone with a question before we move to the next question?